So what do we mean by cube? Cube is an industry standard term we use for a multi-dimensional table of data. So most people are accustomed to two-dimensional tables of figures. When you try to represent more than two dimensions in a simple table or a spreadsheet, it becomes very difficult to consume and navigate for doing very simple analytical tasks like comparing two products or evaluating trends and so on. But let's start with a two-dimensional table and add to it. So here's a list of products I sold at my store today. The list is the product, the quantity I sold, the selling price, and then the product of price and quantity, so how much I actually made from that product. This is very easy to look at in a two-dimensional table. But what if I want to see a product, a particular product, for every day this week? What if I have other stores and I want to compare my product performance in one store or another, or I want to see the performance of those stores over time? Cubes make it very easy to navigate, summarize, filter, and calculate my data to answer questions like this very quickly. So here's a representation that'll probably be a bit more clear than my drawing and maybe a bit more familiar. So here's a spreadsheet where we've represented the dimensionality of our data as best we can by adding labels for the date that the product was sold on. We've got rows indicating what our various products are. We've also got columns here showing the measures of our product, so how many we've sold, the price, and what the product of that is. And we've used tabs in this spreadsheet to represent the various stores. Now, the challenge when trying to use this approach on real data is that it falls over very quickly when we try to look at things in a number of other ways. So when we think about being a multinational organization, we probably want our price and our gross to be available to the consumers of that data in both a local currency as well as perhaps for them or others a standard rate. If we want to modify the presentation so that we see just units sold, but we see that for each day across time so that we can get a trend or anything like that, becomes very, very difficult with a spreadsheet. In fact, it's one of the key weaknesses of how data is stored and visualized in a spreadsheet that makes them very tightly coupled. So, if we think about televisions, we'd never want to buy a separate TV set for watching every different channel, but when we're working with a spreadsheet, we will very commonly copy data and paste it from one place to another just so that we can see it in a different way or create separate references for that. One of the core value propositions of cube technology is that the presentation of that data is abstracted from the data itself, so we can look at it in a lot of different ways without in fact duplicating the data that we want to see. So let's take a look at a real example of that, and we'll use Cognos Insight to look at that cube. Now here is the same data we were just looking at presented in a cube. Now if we take a look at the cube, which is called store sales here, that's the name of the file that I imported, we see that the cube is made up of dimensions. So there are 4 dimensions, the first being product, so we sell pencils, pens, and notepads, the date that these products were sold on, the store that they were sold in, and then as we can see here, a number of measures about how that was sold. So the number, the price it was sold at, and then the gross. And then the gross, which is of course the product of our units sold times our price. Now a table, we would say, is made up of rows and columns. A cube, we say, is made up of dimensions because of the flexible navigation that cubes afford us. So we're not restricted to rows or columns. I could see this broken down by store, I could see it broken down by date, or I could nest these to see it broken down by store, by product for each date, or I can take a look again at my measures to see those broken down by product and store. So cubes give us a very flexible means of presenting data no matter how it was originally structured. With a cube, it's typically very easy to filter and navigate that data as well. So for example, if I want to see my data from January 2nd and I want to focus in on the Jones Drive store, I can just double click here to filter on that. I could filter on a particular product. So for example, here I see the breakdown for pencils across each store and then a total for those. And that very fluid navigation and filtering experience is another one of the key value propositions of storing data in a cube. So this flexible navigation is something you'd find in many cube technologies, or OLAP technologies as they're called. What's unique about TM1 is that I can also perform data entry in that same cube space. For example, if I want to forecast my units sold, we'll just focus on our units sold here. I'll add my days and remove my zero suppression so that I can see all days. You'll see how I can very quickly create my own forecast. So for example, if we want to look at a specific store, I could forecast probably the same value for my pencils for the rest of the year. It's just a simple quick command there so that I copy my values. Or I might want to do a forecast at each level. I'm not going to do this for every day, but very simple for me to do that sort of data entry very quickly in the cube. And because I'm using TM1, I'm actually not constrained at entering data at the leaf level as you've seen me do here with the shortcuts and just entering simple cells. I could also do that at a consolidated level. So for example, if I think I'm going to have a great month for pencils here, I could update this to say I'm actually going to do 624 pencils and then choose how I want to spread that. So do I want it spread equally? Do I want to do it based on a proportion, so some other product I'm selling or perhaps a previous forecast for the same product? Or I could do that with a repeat leaf, so just enter the same value in every leaf element. So for my months, enter the same value for each day. I just want to do my proportional spread here, and you'll see that that's doubled my forecast for each day. And I can do these types of consolidated spreads at any level in the cube. So I could update my forecast for all products, all stores, all time periods, that sort of thing. So let me back out my changes now, and we'll take a look at some of the other reasons that we might want to use TM1 as our OLAP technology. Another very powerful capability that comes with storing data in a cube is how easily I can create expressions. So for example here, when we imported our data, we had a gross already, but if I wanted to create one here, I can just do a simple calculation of my units sold times price. And that calculation is true for the whole cube. So whether I'm looking at product by store, or if I'm looking at stores by date, that calculation persists and it's present everywhere I look at it in the cube. You can imagine, of course, that if this were a spreadsheet, I would have actually had to create a whole bunch of cell expressions for everything that I wanted to calculate, rather than a single calculation that I can use throughout my data set. And because I'm using TM1, of course, is my cube engine that we're talking about here, I actually have a lot more flexibility and power in my calculations than what we're looking at here, because I can scope those to just apply to a very specific portion of my cube. So you know now that cubes are just a means of storing data in a multi-dimensional table which allows for flexible navigation without the need for creating redundant copies of that data just to explore, drill, slice and dice around that. You know that expressions can be created in a cube just once but be used throughout that cube. And you know that you can use that cube to do data entry at any level in the cube. So if I want to enter a specific product for a specific day for a specific store, or at the month level for all days in that month, I can still perform my data entry at that level. I can also use shortcuts to make that detailed data entry much faster and easier. So with that in hand, why not try out a simple exercise to get familiar with navigating and exploring a cube?